All right, here's video number 2, example 2 for section 11.5. In this one, we're going to look at some sample results and see how we can come up with some inferences or results of these actual samples. So here we got a table that has some different samples with their sizes, the number of votes or the results that were achieved from these samples, and the percentages that we got from those. So let's look at the problem first. We've got a student newspaper wants to predict the winner of a mayor election. There's only two candidates running. This is important. Candidate A and candidate B. They're running for office. So 8 staff members went out and conducted surveys of randomly selected residents. And the residents were asked which candidate they're going to vote for. Now, actually, they were asked if they'll vote for candidate A. Okay, so these results right here are whether or not they will vote for candidate A. And in this table, we have the percentage of votes for candidate A. Let's look at the questions. So based on the results in just the first 2 sample surveys, so that's these 2 right here, rows 1 and 2, do you think candidate A will win? And then explain why. So let's look at these first 2 results. The first one, there was a sample size of 5 people. 2 said that they will vote for candidate A. And that works out to 40%. So you take 2 over 5, that works out to be 0.4 or 40%. In the second, we had 4 said that they will vote for candidate A, and our sample size was 12. So 4 over 12 is 1/3, which is 0.333, and we get 33.3%. So this question is just asking us if we think candidate A will win based on these 2 samples. Now, what you realize, or what you have to know, is that since there's only 2 candidates running, then in order to win, a candidate must get more than 50%. With only 2, they need to have more votes, which will be higher than 50. So since you see right here, these results, you can infer that they will get less, candidate A is going to get less than 50%, therefore candidate B will win. So here's the answer that they give. So out of these 2 samples, which are out of 5 and 12 people, fewer than 50% will vote for candidate A. So because there's only 2 candidates, we can say that based on these 2 samples, candidate A will not win. Okay, so that would be our answer for the first question. Based on these 2 samples, that candidate A will not win. Let's look at the second question. Based on the results, so all of the results in the table, do you think candidate A will win the election? Explain. So as we start to look at larger and larger samples, we see that the number of votes for candidate A goes up. So in our third sample, we see that 12 out of 20, or 60%, 17 out of 30, 56.7, 29 out of 50, so 58, 73 out of 125, 58, 58.7, and 59. Now, this is just like the sample or the examples we did in class today with rolling the dice and seeing that when your sample size is small, there's more of a margin for error. What that means is that you may interview just 5 people, and a majority of them may say that candidate B is who they're going to vote for. It's like flipping a coin. It's 50-50 that heads or tails will come up, but if you flip it 5 times, you may have 3 heads and 2 tails, or 4 heads and 1 tails. That doesn't mean that heads comes up 80% of the time, but it means in that experiment or in that sample, our percentages are skewed a little bit. So since we see that as our sample size gets bigger, these numbers approach 59%. So what we can say, as the sample size increases, the estimated percent approaches 59. Now, since there's only 2 candidates, and we see that 59% seems to be our likely outcome, we can say that 59% of the residents will vote for candidate A. Therefore, we can feel confident that candidate A will win the election. So that's how you analyze some of the data. You have to realize that as you're taking polls or surveys to try to predict outcomes, it's really important that your sample size gets large enough to be representative of the population as a whole. The smaller your sample size is, the less precise or less accurate your results become. So what I want you to do is, you've got another similar table right here. This one has to do with a cafeteria manager asking the students which food they're more likely to go with. So you can read the question here, or read the situation, look at the data, and then answer the two questions. And I want you to explain, put some explanation with your answers. Tell me why you wrote down the answer that you did. So again, don't just give a one-word answer. I want you to explain why you selected the answer. So back up your results. Give me some justification for your answers. Go ahead and do that now.